at line graphs again, and we're going to look at reading and solving problems and interpreting line graphs. So, we've got a line graph here that shows overnight temperature, and we've got a line which tells us what time the temperature was taken, right from 10 o'clock at night right through to 6 o'clock in the morning. And then up the side we've got temperature. Actually, whoever drew this graph has forgotten an important thing, because what should they have put along the side?
Is it a measure?
Yes, the unit of measure. So it's all very well to put the scale, but what are we measuring? What is the unit of measure? What would you expect that to be? What would you expect the unit of measure to be?
Degrees.
Degrees, yeah, degrees centigrade, yeah. So, it starts at -4 and then goes up to 8. But yeah, you would expect it to be labelled so that it's nice and clear. Okay, so, what was the highest and the lowest temperature? What was the highest temperature recorded?
7 degrees.
7 degrees, and that was at 10 o'clock. And if you use the lines to help you, you can see that's be nice and easy to read following the lines. How did you know that was 7 degrees though? Because it only labels it 6 and 8. How did you know that was 7?
Because it's halfway.
It's halfway between. Good. What was the lowest temperature?
-3.
Good. How did you know?
Because it's halfway between the
It
two.
is. It's halfway. If you took a ruler, I'm just doing it with my finger, but if you took a ruler and measured across with your ruler, got a straight line across, it will be -3. What time was that temperature recorded for -3?
4 o'clock.
4 o'clock in the morning. Good. Okay. What's the difference between the highest and the lowest temperature? So from -3 right up to 7, how many degrees has it travelled from -3? -2, -1, 0, right up to 7.
11.
Another go.
10.
10. Yeah, count with me. From -3. -3. -2, count with me. -2. -1. 0. 1. 2. 3. 4. 5. 6. 7. We've gone up 10 degrees. So the difference will be 10 degrees. How long did this temperature stay at freezing point or less? What is freezing point?
0.
0. Good. Okay, so reach 0, 1 o'clock, and then it came back up to 0 at 6 o'clock. So how long did it stay at freezing point or less?
6 hours.
6 hours. Good. From 1 o'clock in the from 1 o'clock in the morning to 6 o'clock in the morning. 5 hours. Yeah. From 1 o'clock in the morning to 6 o'clock in the morning. 5 hours. Good. Okay. How does drawing vertical and horizontal lines support me in reading the line graph? They've actually drawn, well, they've probably not drawn, they probably did that on square paper. But do the squares help you to read the graph?
Yes. Yes.
How?
If you have it dead on the minute, it's like 8. If the line was there, you would know that it's definitely there.
Yeah, it does help you to follow it through, doesn't it? And to read it really carefully and be accurate, because it's important to be accurate. Remember with a line graph, the important difference between a line graph and any other graph is that the points in between also mean something. So if I wanted to know, for instance, the temperature at 12:30 midnight, the point that I could find that, even though it's not plotted, I could find it using the line graph and just drawing a straight line with my ruler, or just putting my ruler on there and then taking it across to find out that the temperature was 1 degree. So the points in between also mean something in a line graph, which they don't in other graphs. Okay, let's have a look at another slide. This one is somebody who has measured their heart rate during exercise. Remember when we're doing a graph, how do we remember which way round we put the data, what we put on which axis?
You do something, you change.
Good. Remember on the bottom you have something that you change, and then along the side, something that you measure. And you get to take measure to remind yourself it's something that you measure. Good, okay. So, along the bottom we've got time. Unfortunately, what's the problem with this graph?
They've missed out what they're measuring in what time.
Yeah, they've said time, but they haven't said what unit to measure. Is it in seconds? Is it in minutes? Is it in hours? Not really very clear. From the questions, I think you would understand that, but always put your unit to measure. And then the pulse rate, again, they haven't actually explained the pulse rate. That will be in beats per minute. So you probably put that on there as your unit to measure. Okay, how long did it take for the pulse rate to reach the highest level? Explain your answer using the graph to help. Well, it reached its highest level just here. So, how long did it take to reach its highest level?
5 minutes.
5 minutes. We're assuming a minute, so we think 5 minutes. Good. What could have happened at 5 minutes? If that person has raised their heart rate, what could have happened?
You could have done something active for a good length of time. And
Yeah, they could have started to run or skip or do something really energetic. Okay. What could have happened at 7 minutes? Because at 5 minutes and 6 minutes and 7 minutes it levels off but at the highest rate. And then it gradually starts to fall a little bit. So what could have happened?
when you go on a run, you do eventually get tired, so maybe you didn't have that much stamina and start to wear off.
Yeah, good point. Well done. Okay. Estimate what the pulse rate was after 2.5 minutes. How did you get an accurate estimate? So, after 2.5 minutes, what will I need to be able to get an accurate estimate? Big clue? What will I need?
Ruler.
A ruler, good. And I'm going to put it on the 2.5 minutes and take it up to the line, and that on my measurements is level with 80 beats per minute, so it'll be 80 beats per minute. So you need to make sure you're using a ruler to help you to get a really accurate view, an accurate meeting of the line. Okay? Really important when you're using line graphs to be accurate. If you put your ruler on a slope like that, or like that, you're not going to get an accurate measurement. So you need accuracy, it's very important. Okay, one more slide. What would you need to consider if you were going to collect your own data? Let's think about the temperature one. Can we measure the temperature in our classroom? How could we gather the data? How could we present the data? What do we need to think about if we're going to collect data for the temperature in our classroom?
Well, you have to think about how you're going to collect the data. For temperature, I would probably use a thermometer.
Good. Okay, so we would use a thermometer. Yeah, that's the first thing. We need to accurately measure it. So we'd use a thermometer and we measure it in degrees centigrade. Okay, what else would we need to think about?
What time?
Yes, what time? And it would be important to do what during the day?
Do the time periods, maybe do, let's say you started at 1 o'clock, then you could do maybe another hour from then and then do that data.
Good, yes. It would be important to measure it at regular intervals. It's no good if I came in at 7:30 and measured the temperature and then I forgot about it until lunchtime and then measured the temperature and then we did it at 1 o'clock and 2 o'clock and 3 o'clock. That would be very uneven, wouldn't it? And it would be very difficult data to deal with. We need the data at regular intervals, so we pick a time to start and then, as you say, go in hourly intervals or half-hourly intervals or 2-hourly intervals throughout the day so that data is evenly spaced. So we need accurate data, we need it at regular intervals, okay? How would we record it? Would we put it straight onto a line graph?
No. you would record it on something you would remember. Then when you finish recording all the data, maybe on a piece of paper, then you would add it to your line graph.
Good. What form would be nice and easy and straightforward? Yeah, a grid or a table. Yeah, it would, yeah. Like the ones we looked at yesterday for the rainfall, where it had months down there and then the amount of rainfall in the next column. So yeah, we want it in a nice straightforward grid table, so it's nice and easy to read, nice and clear, and then we can put it onto our line graph. Okay? So we're going to go have a go at some chili challenges, and then we'll look at the plenary together.